This video is the beginning of our next unit. We are finished with our probability unit, and now we're going to start something called inferential statistics. And that's a branch of statistics that uses sample data to make generalizations about a population. So a couple of terms that you need to be familiar with are estimation, sample data that we collect, because remember, it's really difficult to get information from an entire population. So we generally take a random sample of the population, and then we use that to estimate the value of whatever it is we're looking at of the whole population. So the population parameter. So that is what estimation is when we talk about estimation in inferential statistics. And then sample size, that is the size of our sample that we have taken. That's how many observations sometimes we need to figure out how many we need to include in a sample to get a certain level of confidence. But sample size is how big our sample size is. That's pretty straightforward. And we note a sample size with the letter N. Okay, and then hypothesis testing, that is something that we're going to talk more about next week, but we draw conclusions based upon past experience compared to present day samples. All right, so point estimate, that is a term that you need to be familiar with. That, if it's a proportion, it looks like this, and it's called p-hat. And then the point estimate for a mean is the sample mean. So those are guesses, and I'm going to give you an example. The election is coming up, or the primaries are coming up on Tuesday. And so I dug around and I found a poll taken by Franklin Pierce College. And that's in New Hampshire, and it was taken on February 6th, so last week. And in that poll, they polled 454 likely Democratic voters, and they asked if they were voting for Bernie Sanders. And out of that 454 sample, 140 said that they were voting for Bernie Sanders. So the first thing I'm going to do is I'm going to write down my sample size. So the sample size was 454. The number of people who said that they were going to vote for Bernie Sanders was 140. Now, am I looking for a mean, or am I looking at a proportion? If I'm looking for the number of people who intend to vote for Bernie Sanders, well, that's not really a mean. That's going to be a percentage or a proportion. So I'm looking for p-hat. So I'm going to get the percentage of people who are voting for Bernie Sanders, and that formula is x over n. And that gave me a value of 0.3083, so 30.83%. This is how I find my point estimate. It's as simple as that. I take a sample, I figure out how many people have that characteristic I want. In this case, I was looking at Bernie Sanders voters, and I find the percentage or the proportion. So here in the middle of this diagram would be my point estimate. And I'm going to go ahead and label that. Now, when I looked at the poll data, they said that the margin of error was plus or minus 4.6%. Okay. Generally, when I do a confidence interval, or anyone does, I like to draw a diagram, kind of like a normal distribution. In here, this is my confidence interval. Right in the middle is my estimate, my point estimate. And then out here would be, if the percentage were out here somewhere, that would be an error. And we call the error alpha, but since it's on both sides of my margin of error, it's actually alpha over 2, because you have to divide that error in half. And since that whole proportion, all of the possibilities, has to add up to 1, this is 1 minus alpha. So if I'm looking for the value that is the lower bound here, since the margin of error is 4.6%, I'm going to take 4.6 and subtract it, or 0.046, and subtract from 0.3083, and that value is, hold on a second, 0.2623. And then to get the upper boundary, I'm just going to add 0.046 to 0.3083 instead of subtract. And when I do that, I get 0.3543. So depending on what my confidence level was, let's say I have I wanted a 95% confidence level. And that's how I calculated things. I am 95% sure that the real proportion of voters is going to be between 0.2623 and 0.3543. I mean, when you take a sample and you extract data from it, it most likely isn't exactly the same as the population data, but that's why you have a point estimate, and then you have a range around it where you think that the real value lies. So the margin of error measures the accuracy of the point estimate. It's like a give or take a few points. And so the level of confidence, or the expected proportion of intervals that contains, are the expected proportion of intervals that the parameter, if a large number of samples are taken, that contains the parameter, So just like in class, if our level of confidence increases, our margin of error also increases, right? That confidence interval width gets bigger. One way to combat that is to take a larger sample, because more data from your population is going to make your prediction more accurate. So that is one way to make your margin of error smaller. All right, so if we only have the confidence interval and we want the point estimate, then we're going to take our upper boundary and our lower boundary, and we're going to take the average of it, and that will give us our point estimate. So, and then the margin of error is the upper boundary minus the lower boundary, and you divide that in half. So the example I have is I have a lower boundary of 0.051, which would be 5.1% of something, and my upper boundary of 0.074, which would be 7.4%. So whatever data that's from, they're saying that we think the actual proportion is between 5.1 and 7.4%. So I want to find the point estimate itself. I'm going to take 0.051 and add it to 0.074, and then I'm going to divide that in 2, and that gives me a point estimate of of 0.065. So we think that the point estimate is 6.5%. So it's as easy as that. And then if I wanted to find the margin of error, if I have the point estimate, I could subtract that from the upper boundary, and that's the distance between the middle and the top, or the middle and the bottom. But if I don't have the point estimate, I can take my upper boundary, 0.074, subtract my lower boundary, 0.051, divide that in 2, and that gives me a margin of error of 0.0115, so 1.15% margin of error. Well, that's a pretty crappy looking M, and O for that matter. But that really says MO, not MD, not NDE. Okay, so how do we interpret a confidence interval? I have a couple of examples here. Sleeping. We created a 90% confidence interval for the number of hours that full-time college students sleep during a weekday. And we found that it has a lower bound of 7.8 hours and an upper bound of 8.8 hours. And we want to interpret the confidence interval. So the first thing we're going to do is we're going to find the point estimate. And if we look at this, this is not a proportion. These are a value, not a proportion. So we're going to go with mean, and we're going to take and find the point estimate. So we're going to add the upper and the lower, and we're going to divide that in 2 for the point estimate of 8.3. And then I want to find the margin of error, and that's going to be 8.8 minus 7.8 divided by 2, which gives me a margin of error of 0.5. So half an hour. So how I interpret that is, I would say we are 90% confident, and this is really important, and I know it's a drag. That's why most math teachers don't really like statistics very much. One, we're only 95% confident of our answer, and we like to be 100% confident. So we don't like that. But also there's a lot of writing involved, and most math teachers don't like to write a lot. Anyways, so you need to write, we are 90% confidente, that full-time college students sleep 8.3 hours plus or minus 0.5 during weekdays. And you would need to make that full statement in order for it to be accurate. All right, let me see if I can find my little eraser. Good, because I'm going to need some room. All right, so here we go, part 2. This is about superstition, and it comes from a USA Today Gallup poll. They asked 1,006 Americans how much it would bother them to stay in a room on the 13th floor of a hotel. So interestingly, the poll indicated that 13% of them said that it would bother them to stay on the 13th floor of a hotel. And the margin of error was 3% with 95% confidence. So the point estimate here, oops, got to get my pencil back. the point estimate, I don't even have to calculate. They told me what it is. It's 0.13 because the sample indicated that 13%. So that's all I need for that. But I want to construct a confidence interval for all of the Americans, who would be bothered by staying on the 13th floor. So if I draw this out, okay, and my point estimate is 0.13, and I know that my margin of error is 3%, so I would add 0.03 to get the upper boundary, and I would get 0.16, and if I subtract 0.03 from 0.13, I get 0.10. So my confidence interval is 0.10 to 0.16. That's the interval. That's the range of numbers that I think the population value is of Americans who would be bothered by staying on the 13th floor of a hotel. So if I write it out, we're going to say the number of Americans, have to be very specific, who would be bothered by a stay on the 13th floor of a hotel is 13% plus or minus 3% with 95% confidence. So I'm going to erase this. So pause this if you need a minute to write this down, because I need to interpret the confidence interval, and I'm going to need the space. And then you can start it back up to write the interpretation. But I need to erase this so I have room to write the interpretation. Okay, so to interpret the confidence interval, we would say we are 95% confident that the proportion of Americans who would be bothered by a stay on the 13th floor of a hotel. I hope I don't run out of room. Is between 0.10 and 0.10 and 0.16. So that was the introduction I wanted to get to you in class, and now you can go ahead and watch the second video. Try not to be bothered too much by writing out the statements. We'll practice that in class some more. and hope you have a good weekend.